Alright, we are now at part 3. Vectors. This is a long section. Alright, let's keep going. So I would like to do one more U-try from the previous section. And so I would like you to draw the resultant vector here, starting with vector C, which is south 25 degrees west, 60 miles, and D, due east 90 miles. Alright, let's draw our compass guy here. Compass? No. North, east, south, west. Oh, I should have drawn it. Oh well, it's okay. So south, so we're going to have 60 miles and 90 miles. So let's decide. Let's do quarter of an inch equals 10 miles. Okay, so we first have south 25 degrees west. So that'll be, start with south, 25 degrees to the west. So we'll say that's about 25 degrees. And we go 60 miles that direction. So each quarter of an inch is 10 miles. So I need 6 of those to get 60 miles. 1, 2, 3, 4, 5, 6. 6 quarter of an inches will get me 60 miles. 60, not 60 degrees, 60 miles. And so this was C here. And then we're going to go due east 90 miles. So due east, so that's this direction, parallel with the east-west axis. So we want to go 90 miles, so 9 quarter inches. 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. And that was D. And we've gone due east. And so now I want to know how far I've gone. From my original spot here to the end. And so this is C plus D. So I want to know this degree measure here. And I want to know this distance. So let's find the distance first. So we're going quarters of a mile here. So a quarter of an inch is 10 miles. So 1, 2, 3, 4, 5, 6, 7, 8, about 9 quarters of a mile of an inch, which times 10 would be 90 miles. So we've got about 90 miles. That doesn't sound right. That shouldn't be. Well, I guess it could be, couldn't it? Yeah. Alright. So 90 miles, about 90 miles. And then this angle measure here, so it'd be great for you to have a protractor here and decide what this angle measure is. And we're going to say it's about 50 degrees. And so this is south 50 degrees east. So if we start at south, we're going east 50 degrees. So we go south 50 degrees east. Approximately 90 miles. Alright, so that's my resultant. Now let's go ahead and look at this next concept here very briefly. And this is zero vector. what this means, or what this looks like, is a 0 with a little vector sign on top of it, or just a 0, a bold 0. An example of this is if I were to have A going this direction, and then negative A, notice how they're the same magnitude, and they are going the opposite distance, or the opposite direction, same magnitude, opposite direction, then I say A plus negative A equals 0. So this is an example of a 0 vector. If you add opposite vectors together, you get 0. All right, let's keep going here. We're going to do multiplying vectors now. Multiplying vectors. If k, which is a scalar quantity, is greater than 0, then k v here has the same direction as the vector. So we're saying if it's a positive number, it's going to go the same direction when you multiply them together. If it's a negative number, k is less than 0, right? So this would be positive, or this one would be negative. K is less than 0, we've got negative, so k times this vector, then we're going to have the opposite. Direction. All right, so let's look at some operations with vectors here, now that we know that this little bit of information. Operations with vectors. So our first example is going to be, we're going to draw a vector diagram of 3 vector x minus 3/4 vector y. All right, you got to know what x and y are though. X is 1 centimeter. And if you don't have a metric ruler, it's okay. You can still just kind of be approximate here. So this is x, this is vector x, and this is 1 centimeter. And then vector y is going to be like this, and this is going to be 3 centimeters. Okay, so these are the vectors that we're working with here in this expression. And now we're going to do this. First, I need to make 3x. All right, so 3 times x is 3 times 1 centimeter, right? Because x is 1 centimeter. Multiply that by 3, so I get 3x. So here I go. The same direction. So now I'm going to call this one 3x, like that. Or I could just say 3x without the little vector guy on top. That's fine. So that, again, I'm going to write it again. This is 3 centimeters now. And then 3/4 y, but also notice there's a negative here, so it's minus that. So now I need to go ahead and switch it the other direction. So before it was going this way, now it's going to be going the opposite direction, but I need to figure out what that length is going to be. So negative 3/4 y. So it was going up and to the right, now it's going down and to the left. And so I've got to figure out what this distance is here. So this one is 3, so 3/4 of 3 centimeters. So if I were to do this math here, I would end up with 3, so let's do it right here, 3 times 3/4, right, 3/1. So that'll get me, and it's going to end up being negative. We can just keep the negative there. So that's 6/4. I mean 6, 9/4. Yikes. Okay, so if I were to reduce this, and I can use decimal points because I'm in metric, so this would end up being 2 1/4 or 2.25. So I'm going to draw this here. 1, 2 1/4, which is about right there. 2.25. That is my new vector here for y that I've drawn. Now, the last part of this, so I start with my vectors, and then I make these manipulations here, I do these operations, and I have my new vectors here. And now I need to find the resultant vector that, that is going to be the subtraction here of these two. So I'm going to do the triangle method of finding my resultant. So I've got 3 centimeters, 1, 2, 3, oops. And then I'm going to do 2.25 in that direction, 2.25. There we go. So this one was 3x, and this one is negative 3/4 y. And then I connect these two guys. And this is going to be my 3x minus 3/4y. That's my answer. Not too bad, right? Let's have you guys do one. And this is vector m minus 1/4 vector p. So m is going to be 3 centimeters, and it's going to go this direction. And p is going to be 4 centimeters and go this direction. Four centimeters, that's p. All right, so based on what we just did here, go ahead and pause and do this one. Now, okay, so there's no manipulation to do to vector m, because it's just m here, it's not times anything or divided by anything. So we're going to leave that one the way it is. I'm just going to redraw it at that angle. So 1, 2, 3. 3 centimeters, and this is m. And then I'm going to do 1/4 p, and I've got to flip it the other direction too because this is minus. So 1/4 of 4 centimeters is 1 centimeter. So that's going to go 1 centimeter, but instead of going to the right, it's going to go to the left. it is. This is negative 1/4 p, and that is just 1 centimeter. And then my resultant here, I'm going to draw this from the beginning to the end. So this should be 3 centimeters over here. So here in bold is my resultant vector, which is vector m minus 1/4 vector p. Cool. Hope you guys got that one all right. And we're going to keep going. We got a little bit more here. Solve navigation problems. All right, so we have an airplane flying 310 knots. Airplane flying 310 knots at a heading of 50 degrees. There is a 78 knot wind from 125 degrees. Determine the speed and direction relative to the ground. So let's draw our north, south, east, west, north, south, east, west. Now we're going to draw this without being super precise here, because we are going to use our math skills to be precise. So we've been doing this kind of thing and approximating quite a bit. For this one, we're going to try to get as exact as possible with our answer. So we just need to draw it. It's okay if we're not perfect with our drawing. We want to be perfect with our answer. So I'm going to say this is about 50 degrees, right? So we start, this is the true bearing from north, 50, so this is about 50 degrees. And then the 78 knot wind, so this is 310 knots. And then we have the 78 knot wind from 125 degrees. So 125 degrees, so I'm going to start that right here. And I'm going to find 125 degrees. So this is the same true bearing, right? So 125 degrees. So if this is 90 degrees, and then how much farther to 125 is 35 degrees. So it's going to be about right there. Now it's from 125 degrees, which means it's going that direction. So I'm going to say from 125 degrees. So it's going to the left, up and to the left, this way. So this is 78. All right, and so now what I want to find is this distance here, and I want to find this angle here. That angle and this distance. So how can I do that? Let's think about some of the things that we do know. We're going to be using some trigonometry here for this. Oh, sorry. There we go. So I don't know this angle. I don't know this angle, and I can't know this angle, but I can figure out this angle. And so let me show you how. Now, I know that this angle here, if this is 50 degrees, then this one is 40 degrees. Okay? I know if I were to draw this horizontal line here and this horizontal line here, then I have parallel lines, which means that this angle and this angle, with the transversal going through these two parallel lines, these two opposite interior angles, alternate interior angles, are congruent. So this is 40 degrees right here. Now I also know that this is 125 degrees, and this goes up that direction, right? So I need to figure out, I can figure out what this angle is based on that information. And I might need to draw it again just to kind of help me see what's happening here. So if this is 125 degrees, then this little bit here is 35 degrees, and this is 90. So I want to figure out what this part is. So if I were to look at this line and this line, 35 and this, these are vertical angles, so this is 35 degrees. So that means this piece right here is 35 degrees. So this whole angle is 40 plus 35, so this whole angle in here is 75 degrees. Alright, hopefully you're kind of sticking with me here. Now I have an angle and I have two sides. I have the opposite side and another side. This is not a right triangle, and so what I have to use is law of cosines in order to find the information that I want. And so I'm going to say, so I know what, oh, you know what? Did I use law of cosines last time and I didn't need to? This is 78, this is 30. Let me redraw this triangle so that it's a little more clear without all of that extra stuff in there. Oops. Okay, so this bottom side is 310. This one up here is 78. This angle is 75 degrees. I want to know this. I'm just going to call this X. And I want to know this. This is going to be A degrees, we'll say. Okay, so I need to find this side and this angle. So let's use some, let's use law of cosines. So we're going to say x squared, that's what I want to know, equals the two sides that I do know that are not across from the angle. So that's 78, should I write? No, 78 squared plus 310 squared minus 2 times those two, 78, 310, times the cosine of 75. So if you remember, the law of cosines is c squared equals a squared plus b squared minus 2ac times the cosine of angle C. where C is the side that's across from the angle. All right, now if I were to go through all of this mess, I would end up with x squared equals 89,667.51. And so that means that the vector, if I take the square root of both sides, the vector is approximately 299.4 knots. All right, so I have my distance. Now I just need my my other angle that's here. Now, once I find this angle, I might not be quite done yet because I need to figure out my my heading with the right notation. So let's see. Sine of 75 degrees over my x value here, which is 299.4, equals sine of my a, well, that should be a big A, right? Sine of a over 78. And now I solve this. Remember trigonometry? So let's see if we can figure the rest of this out. So if I were to multiply all of this out together, right? So I say I can do it like this, right? And then I end up with sine of inverse sine of 0.2516 is what I end up with, right? So I end up with sine of a equals 0.2516. So I do the inverse sine of that, and I end up with about 14.6 degrees. So that is this angle right here. Now, if I have that angle right here, and this whole angle is 50 degrees, I need to find this angle is what I'm looking for here. So I need to say 50 minus 14.6. Oh my goodness. 50 minus 14.6, and that gives me 35.4 degrees. So that is my angle there, but let's write it in the correct notation. So here's my distance, my magnitude, and now I need to write this the correct way. So this angle here is 35.4 degrees. So I say north 35.4, east. So that's my answer. Whew! That was a big one. All right, let's keep going. We only have one little bit left to go for 8-1. This is the mega section. All right, 8-1, the last page. Resolve a force into rectangular components. All right, so here's your example. We're going to mow the lawn. So first we need to draw a lawnmower. So there's kind of the top. There's the part that has the fan in it. And then here are the wheels. And then here is the handle. And here's the grass. All right, lawnmower. So when you push on a lawnmower, you push down with this force, and this is 450 newtons, and this is 56 degrees. Now we're going to draw this with rectangular proportions here. Now we're going to draw components, sorry. Draw the rectangular components. So we're going to draw this as a triangle. We've got X, we've got Y, we got 450 newtons, and so the Y is the down, we're pushing down, and the X we're pushing to the left, and this was the original force here, the 450 newtons at this angle. And so we've drawn it there, so these are the components X and Y are the components. So notice we have an angle, and we are drawing the components are just vertical and horizontal. And so that's how we're breaking this this diagonal vector. We're breaking it down into vertical and horizontal components. That's what we're doing. All right, so we are going to just look at a couple examples and find the magnitude of vertical and horizontal components. Okay, so we're going to use this example. We're going to keep going, and then so if I have this triangle, we know this is 56 degrees, we know this is 450 newtons, and this is Y and this is X. So what we're going to do here is we are going to take the cosine of 56. Why would I use cosine? So remember, cosine is opposite over hypotenuse. So remember that we're going to use SOHCAHTOA. And so cosine is cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So I'm trying to find this X value. So X over 450. Adjacent over hypotenuse. Cosine is adjacent over hypotenuse. So now I'm going to just multiply both sides by 450. Cosine 56 equals X. And so X is approximately 252. And then now I'm going to have sine of Y. So sine of 56, I want to find Y, is opposite over hypotenuse. Sine is opposite over hypotenuse, so Y over 450. Multiply both sides by 450, so I got 450 sine of 56 equals Y. And now we want to do the absolute value of Y, and we'll just see that you might get a negative number here, but we need a positive one because these distances are always going to be positive and not negative. 450 times sine of 56y, and make sure that your answer is positive, is 373. So I have these absolute value signs that it needs to end up being a positive number. All right, so we have broken down those two components, and that is our answer, X and Y. And there we go. Now, you try. I've got a guy, and he kicks this ball. And the ball goes whoop, like that, 44 feet per second at an angle of 33 degrees. So first we're going to draw a diagram. And 2, we're going to find the horizontal magnitude and the vertical magnitude to the nearest hundredth. Okay, so follow this example here, drawing all of the pieces together here, and then use your trig functions to find the answer here for horizontal magnitude and vertical magnitude. Pause and work. Okay, welcome back. And the diagram you drew should look something like this. 44, 33, and this should be y, and this should be x. And then you should find the opposite over hypotenuse, so that would be sine. Sine of 33 equals y over 44. And cosine adjacent over hypotenuse. Cosine of 33 degrees equals x over 44. Now, as you multiply both sides by 44 and you calculate that in your calculator, you should have gotten, for the horizontal magnitude, which is the x1, you should have gotten 36.90 feet per second. And the vertical one, which is the y1, you should have gotten 23.96 feet per second. And you can look at that to see if it makes sense. Notice how this is 33 degrees, so you know the y is going to be smaller than the x value. And look here, we have the y is smaller than the x value, so at least that's one way to kind of check to make sure you've done done this right. All right, and that is the end of 8-1.